Stop prompting and start designing loops. In this video, we'll explore how shifting from typing every instruction to building small, automated systems can help Claude do the work for you. No coding background is required. Today we'll cover the shift from prompting to loops, the 4 types of loops, the setup and skills you'll need, plenty of practical examples, real-world case studies, and how to build your first loop this week. The core shift is simple. Stop prompting and start designing loops. The professionals who succeed will be those who can clearly define what done looks like, allowing the machine to reach that goal independently. What is a loop? It's agents repeating cycles of work until a stop condition is met. Remember, you're already using loops every time you use an AI tool, but you're currently the bottleneck, manually throwing the stick and checking every single step. Currently, your workflow likely looks like this: read, write, check, and hand back. You are the one who constantly decides if the work is good enough, meaning every single lap ends at your desk until you trigger the next step. This manual workflow creates a bottleneck. While fine for one-off tasks, it fails when work repeats, runs long, or has a specific measurable finish line. You end up doing the exhausting work of checking the same thing repeatedly. Loop engineering isn't about writing more code, it's about briefing the machine. Think of it like handing a project to a freelancer. A prompt is a one-time instruction, while a skill is a standing policy the machine follows every time. Comparing the two methods, prompt engineering requires you to be in the loop for every single turn. Loop engineering, however, builds a system where the AI checks its own work against your standards and knows when to stop, allowing you to step out. Think of the 4 loops as a ladder: turn-based, goal-based, time-based, and proactive. Start at the bottom, and only climb to a higher rung when your specific task requires that level of complexity. The first rung is turn-based, which upgrades your standard chat. Instead of eyeballing results yourself, you teach the AI to inspect its own work. It's best for exploring or short tasks where you're still deciding on the direction. A skill is simply a plain text file that defines how work should be verified. When you find yourself giving the same correction twice, that's a perfect candidate to encode as a skill in your project folder. Here is an example: a skill to verify front-end changes. It isn't code, but a checklist of steps, like browser testing and console checks, that ensures the AI actually follows your standards rather than just assuming it finished the job. Next is the goal-based loop. When a task has a clear finish line, you stop the manual back and forth. You give the AI the specific goal, and it runs independently until that metric is proven to be met. This works because an evaluator model acts as a strict judge, checking the worker's output against your condition. It prevents the AI from cheating or quitting early, refusing to accept anything less than your defined target. The most important rule: a goal must be measurable. Avoid vague instructions like, make it better. Instead, aim for objective, countable targets, such as test pass rates or speed scores, because the I cannot prove it met a vague goal. Now let's talk about time-based loops. Sometimes, work isn't a project, it's a rhythm. These loops run automatically on a schedule you set. You hand off the trigger, allowing the system to check inputs or monitor external events consistently. You can choose between running these locally on your own computer or in the cloud. Local loops are great for active development sessions, while cloud routines can keep running even when you've closed your laptop. Loops aren't just for code. Most daily work is functional and doesn't require programming. Things like summarizing messages, managing an inbox, or checking for stale content are perfect for recurring loops that handle the routine for you. The final rung is the proactive loop. This is where you move from having an AI to having a team. An event or schedule kicks off the work, and the system handles the entire process without you. Building these is simply a matter of stacking what you already know: a schedule, a goal, your established skills, and auto mode. Combine these, and you have a system that works while you eat or sleep, handling the boring, recurring tasks. When should you actually use a loop? Only when the task repeats, runs long, or has a specific finish line. If a task is just a one-off, stick to simple prompting to avoid unnecessary complexity and cost. Let's look at some examples. To build an app from scratch, start simple. Describe your goal in plain English, verify the output like a human would, and set performance targets to keep the iteration process fast and focused. For technical goals, ensure you have a real finish line. Whether it's getting all tests to pass, hitting a specific coverage percentage, or clearing a backlog, having a clear metric allows the evaluator to confirm when the work is truly done. You can also set loops to watch for changes. Instead of manually checking your PRs or deployment status all day, let a loop watch those events for you and only notify you if there's something that specifically requires your attention. For routines that run while you sleep, cloud-based scheduling is essential. Use these for low-risk, high-frequency tasks like morning briefings, nightly bug fixes, or routine documentation updates, allowing you to wake up to a productive inbox. Getting set up is fast. You can use the desktop app for the easiest no-code experience, or use the native installer if you prefer the terminal. All the heavy lifting happens on secure servers, so you don't need a powerful local GPU. This quick reference sheet summarizes the commands you'll need for each loop type. Keep this handy as you start your own projects, from simple chat-based turns to complex, multi-component proactive systems. Familiarize yourself with this terminology: agentic loops, stop conditions, skills, evaluators, and MCP connectors. Understanding these basic building blocks will make designing your systems much more intuitive. Finally, leverage tools and plugins like Chrome DevTools or Playwright to give your loops eyes and hands. Just remember to be selective. Adding too many connectors can eat up your context window unnecessarily. At the extreme, companies like Bun have used these techniques to perform massive rewrites with just a single engineer steering the loops. The lesson isn't that AI replaces you, it's that you can design systems that handle the heavy lifting. To get your loops right, focus on clear standards. Ensure the machine can prove it has finished a task, front-load your context, and always include a limit so a loop can't run indefinitely. Most importantly, fix the underlying system or brief, rather than just patching individual results. Keep your usage affordable by right-sizing your tools and setting clear stop criteria. Start with simple pilot runs before committing to large jobs, match your loop interval to how often work actually changes, and don't hesitate to route routine work to faster, cheaper models. Ready to build? Pick one task where you are the bottleneck. Whether you start by writing a verification skill, defining a countable finish line, or setting a schedule for your work, remember to start small. Your first run will show you where your brief needs sharpening. It is time to stop throwing the stick and start designing the loop. The future belongs to those who can define done clearly enough for a machine to reach the goal independently. Thank you for watching, and good luck building your first system.